All right, this is the Math Models Unit 4 Lesson 1 video. Um, Apologize, don't have a video feed of me, or I don't have my tablet because I'm recording this from home after our snow day. So I'll do my best here, but I think you're going to be fine with these few lessons that we have at the beginning of this unit because it's mostly vocabulary. So this unit is going to be all about how research is conducted in like sort of a scientific way. And so we're going to kind of practice thinking scientifically, and that's going to kind of be the foundation of what we're doing. So there's two main kind of big ideas. Obviously, you need to read over this lesson. It's a good introduction to what we're doing, but there's a lot. There's a couple of key types of questions that I want to make sure you're aware of how to do, which is hypothesis and counterexample. And so, just again, make sure you look over the vocabulary and read through the lesson. But when it comes to the questions about hypothesis, a hypothesis is a testable question. So it's or a testable thing. So like we have a question, we have a research question, and the hypothesis is what we would say we think is true, right? It's like this is my guess or my prediction about what this is, but more specifically, it has to be testable. So it's like it has to be specific enough that I could somehow research that thing. So, like in this first example, I'm going to do question number 1 and then you'll do the rest. It says here for the research question, choose the best hypothesis to test. It says, should the minimum age for attaining a driver's license be increased in my state? Okay, so that's the question. So we know that our hypothesis needs to have to do with that. What does it need to? It needs to relate to the minimum age for attaining a driver's license. Okay, so that needs to be in our answer. So let's read through the answer choices, and then we'll talk about why the correct answer is the correct answer and why the other answers are not. So in this first one, if the minimum age were raised in the state, then there would be fewer accidents among new drivers than there are now. Now, this is related to minimum age. It also has something that we could test, something that we could actually research, which would be the number of accidents, right? It says there would be fewer accidents. That's something that after time we could look at and find an actual answer to that. So that seems like a good one. And I'll talk about another aspect of this in a second. Number 2, answer choice 2, all people like to drive. That is just too vague. It's not testable. There's no way I can just test all people like to drive. Not to mention the fact that it's vague. It also doesn't talk about the minimum age for attaining a driver's license, which is what we're interested in. So that's automatically not going to work as an answer choice. Mark that one out. Next one. There are more reasons for increasing the minimum age than for lowering it. Okay, this one might seem like a good answer at first because it does relate to minimum age, but more reasons, that's not a testable thing. The number of reasons for doing something is not a measurable scientific thing. Reasons, I can come up with any number of reasons. So that's not testable. So that one's no good. Mark that one out. All right. In states with a higher minimum age for driving, there are fewer accidents among new drivers. Okay, so this is an interesting one because it has to do with minimum age and it's also measurable. Okay, so here's the question. Which one of these is a better answer? Because they do both address the topic minimum age for driving and they're both measurable. I could look at other states where they have a higher minimum age and that would be measurable. But the key here to knowing the correct answer is that oftentimes a good hypothesis is stated in this format if then. So, because of that, answer choice A is going to be our answer. So, I'm not going to say every single time it's going to be if then. But and I'll show you where it says this in our up here. It says a good hypothesis is often in the form of an if then statement. Okay, so you look for that, but that's not necessarily always going to be true. That's going to be the best one. But these are the kinds of things you need to look for. So does the hypothesis address the research question? And also, is it measurable? And then lastly, is there an if then version of that? So that's going to be questions 1, 2, 3, 4. And then starting at number 5, it asks this question about counterexamples. So a counterexample is simply something that goes against a hypothesis. So you have a hypothesis, like the ones we just talked about, and you want to know, is there a counterexample? Meaning, is there something that shows that that's actually not true? So these also need to be specific, and they also need to be measurable. So that's where you're going to kind of go through. So I'm going to look at this first one with you. And we're going to go through this one together. So it says most ninth graders students' favorite meal is pizza. Okay, so that's our hypothesis, that most ninth grade students' favorite meal is pizza. Okay, so remember, it has to be measurable in a scientific way, and it has to address it has to be proving that wrong. So looking at this first one, all of my ninth grade friends like hamburgers the best. Okay, at first glance, this one might seem like a good answer because it's saying something other than pizza. However, the key here is this: all of my ninth grade friends. That's not scientific. That's just people you know. That's just random, whatever. That's not scientific. If you wanted that to be scientific, you would need to survey all the ninth graders or something like that. So that's not going to be a good answer. So anytime you have something that's sort of casual or vague or not a specific measurable group, that's not going to be a good answer. Next one. More ninth grade students will choose a meal other than pizza as their favorite. Okay. So that's interesting. But that isn't necessarily a scientific thing because you haven't talked about measuring. So let's keep going. A survey conducted at my sister's elementary school showed that most students there preferred spaghetti to pizza. Okay. Tonight for supper, none of the ninth grade students are having pizza. Okay, just because they're not having pizza tonight, that doesn't tell me anything about overall, right? It's just one day. Let's hop up here and read what they say about counterexamples. So counterexample, find it. All right, with that. Counterexample needs to be, you can prove or disprove this statement by setting up a table and actually giving the 10th grade students a choice. What you hope to find is the opposite, that more 10th grade students pick candy bars. And this is in their example. This would be a counterexample because it proves a hypothesis false. It only takes one counterexample to prove a hypothesis false. So you need to have a survey or an experiment. Okay, that is why when we go down here, we see we have a survey. That survey is what sets these two apart, which is why this would be my good answer choice because I've conducted a survey. And so that's how you know it's a good counterexample. It's not just casual or vague, it's actually something scientific. So again, counterexamples, they go against the hypothesis and they are scientific. They're specific. All right. That gets you through 6, 7, 8, 9, 10. Those are all counterexamples. And then you get to a bunch of vocabulary. So you're going to do those on your own. Please use everything in the lesson to your assistance and make sure that you kind of answer all these. Make sure you note a lot of vocabulary is what's going to be on the test. So you definitely need to focus on the vocab here. And that is it for lesson 1.